All right. Okay.
Okay. Hi. Can you guys hear me okay? Awesome. My name is Nate Day. I head up data science efforts at OSC and do a little bit of relevancy tuning when I'm not too busy doing that. And this is my first time at Haystack, first time giving a Haystack talk. So super excited to be here. And yeah, I'll kick it over to Marc.
Hey everyone, Marc Pereira. I'm Principal Operations Architect at SimpleTire. I've been working on e-commerce sites pretty much my whole career. Worked on all the major sports sites in the US and some abroad. Also major brands like Ralph Lauren, Kate Spade, Burberry, and many more. And throughout all that time, I've been somewhat involved with search. With Solar, Lucene, Verity, if some people remember that commercial product. Now I'm at SimpleTire. And when the opportunity came to work on search here at SimpleTire, I was really excited, you guys will hear some of that now on our talk.
Cool. Yeah. And our talk is titled Using Elasticsearch. We're really going to expound on the flexibility and performance that we got out of using Painless all over the place for all of these custom rankers. So I hope y'all enjoy and here to answer any questions. So we already gave a quick intro of us. Do you want to just give the SimpleTire rundown real quick?
Sure. I mean, well, SimpleTire, so we sell tires online, but really what it comes down to is most people, when they need a tire, it's usually a bad thing, right? They've got a flat or they just have worn down tires and they need replacement. And a lot of people don't know anything about tires, how to find what tire they need or, you know, where to go. And we try to do that like kind of in a all in one place, right? Help you find a tire, help you get it installed, get it delivered, get it installed, just trying to make that whole experience better. And what we're trying to do also that here is we're trying to do that with data and technology, which maybe is a little bit different than some other e-commerce places, but you know, we're working on it. We're trying to make that experience simple.
Perfect. Just real quick, you know, we're the two people doing the talk today, but there's absolutely no way that any of this work gets done without all the people on this slide. This is a range of people at SimpleTire and OSC, from other engineers that wrote code with us to marketing, product leads, vice presidents of digital experience, Rich Sapp, Chris Vital. So we just don't want anyone to come away from this talk thinking me and Marc did everything, and we're very, very grateful to have all of these smart and talented and motivated people working alongside of us. So I'm just going to start out by laying out what we wanted to do or what we accomplished with this project, right? This was kind of an ambitious endeavor. I think we started at the beginning of 2021, maybe started thinking about it right at the end of 2020. And really what we want to do is drive merchandising through our e-commerce, through the SimpleTire website experience, right? And when we say merchandising, what we want to be able to do is kind of be able to balance customer signals, business signals, and bring them all together in a real-time ranking function so that we're able to really maximize that tire buying experience for the customer, right? This gets into blending different attributes of the products in to match different phenotypes of our users that we know from market research. This also gets us into including things dynamically at query time, so we can bring in someone's most recently reviewed products, we can bring in their location, we can bring in all sorts of interesting data that we couldn't before. And we also want to just have these scores essentially capture and embody all of these different features into one kind of streamlined ranked list, right? That's kind of the goal of lots of search. And that's what this talk really is all about, is being able to bend Elasticsearch into a business ranker that we are happy with. And really the bottom line of the business is happy with too, right? So just going to introduce some vocabulary for the talk. We call this merch score. There's an alternate pronunciation, Merc score with a hard K if you go west of the Blue Ridge. But here east of the Blue Ridge, we call it merch score. And essentially it's a multi-component ranking function for search, right? We have it laid out here with 3. Don't get hung up on how many are in there, but essentially it's the blend of these different components that are, like I said earlier, some business, some user, but ultimately the goal is to kind of achieve an optimal ranking, right? And that's what we want to be able to do. And the whole point of this too, of having the components split out, is to give us this ability to remix, right? Choose this here, choose that there, and then blend them together so that we can create custom rankers on the fly and for various situations. So the original merge score recipe, this was something that was created before we ever got started on this kind of Elasticsearch phase of the project. It was crafted through a lot of hard work of marketing research and another group. And we really are standing on the shoulders of giants, kind of taking this and adopting it. They put the work in to figure out which components matter. Here we have user parts of price, ratings, reviews, things that we care about as shoppers when we're going out looking for purchasing, not just tires, but anything nowadays. And then we also have these business components, right? What's the profit margin on a given tire? What's the past sales velocity look like? What's our inventory look like? And what's the distance to that inventory, right? You can imagine these things are big movers and shakers in terms of what it means to get something out to you for that install next day to replace that flat. So the technical details around this, right? I mean, the way we were doing it originally is the first proof of concept was actually in an Excel sheet, right? That was kind of how the first part of this campaign started way back almost 2 years ago. And then we migrated that into a SQL job, and we were running that SQL job essentially every 6 hours so we could get essentially kind of real-time inclusion of this stuff, right? Update inventories and things like that. And then what we would do with Elasticsearch is we would take those scores from SQL, index them, and then essentially sort the results based on that score, right? And this is okay, right? This was working for us all right, and we're pretty happy with it because it was better than what we were doing before, but we weren't quite satisfied. One quick disclaimer here too is that this isn't really a talk about multi-objective optimization. This is more a talk about doing a lot of research around what personas are using your site search, and then getting the ranker to mirror those personas as well as we could, right? So we didn't dive into Pareto frontiers or anything like that in terms of the optimization game, but we think it is super applicable for a lot of other people in the e-commerce domain. So reasons for migrating, right? Elasticsearch is cool. That's one. It's not on this slide, but, and also for what we were doing, one of the big ones was speed, right? Not that MySQL is slow all the time, but for what we were doing inside of the app, it's nice if we can streamline all of the calls out to services or repositories to just go out to Elasticsearch, not have to hit Elasticsearch for IDs and then go back out to SQL to get scoring. The tooling around this is also a massive win for us. So if we can pull all of this into Elasticsearch, it means that we have one place to modify and do all of that remixing and configuring of what's going into the ranker. The SQL implementation we had was kind of hard to manipulate, hard to deliver multiple variants of it at a given time without going in and modifying that original batch job, right? Batching is the next thing, right? Calculating things every 6 hours is great. Calculating things every 15 minutes is even better, right? Being as real time as we could, it pushes us closer to what we know is happening in terms of stock going in and out of our warehouses. And we really wanted to be right there, up to date. And data is something that's kind of a new frontier, right? Being able to do this in real time also opened us up to collecting more data, identifying new data that would help us rank better. And it really ranges the gamut from new things we can store and learn, but it also opens up the idea to bring in other pieces of analytics that we've kind of known from different customer journeys over time, and being able to bring it now into Elasticsearch easily, right? So painless, right? This is painless scripting. I assume most people in the room that have worked with Elastic before are used to painless, and painless, I always heard, was a painful way to do scripting in Elasticsearch, but that hasn't been our experience at all. And this talk, if anything, is kind of a pro-painless talk for getting things in. And so this is just in the Elastic docs about being a performance secure language. It fits right at home for people that have written Groovy or Java in the past. And these are the three big wins that Elastic brings for painless: safety, performance, simplicity. And we're adding on this flexibility bit. I think for us to be able to take existing business logic, one of the biggest things we thought was a risk going in was not being able to port it one-to-one to Elasticsearch. but Painless gave us that door and gave us that conduit to really be as flexible as we want, right? If you can do it with math, with logic, anything really, Painless can do it right there with you. So I'm going to walk through next a step by step of how we actually do this and to build a baseline ranker. So step one, right? Can we actually port the language to Painless, right? Like I said, one of the biggest wins for us was flexibility at large. And we were able to get most of the things exactly as the business had it coded into a Painless template. This is a really simple Painless script right here. And it's essentially looking up the average rating field for a document, pulling the value out of that, checking if it's greater than 4.9. If it is, it gets a 1. If it's not, it gets a 0, right? Super easy if else statement. That's just what it looks like in Painless. I think everyone in developers in the room can easily kind of pick this up. And we didn't really have any trouble figuring out ways to do stuff in Painless. It was pretty easy and straightforward. But still, another step one is Painless is flexible, right? I wanted to kind of drive this point home with a couple of examples of things that we've done. So we've also started to do normalizations on the fly with Painless. If we send off a aggregation query to start, we can do something like min-max normalization on the fly. This keeps us responsive to what filters, what subsets, what other things the user has in place, and lets us get scores that are normalized. This is just one example of how we're using it, but you can also kind of blend in this multi-phase idea where you get params or get attributes of the product set that's being displayed and then use those in a custom ranker. Painless is also, I titled this slide Painless is double jointed just because we were even amazed at some of the stuff that Painless can do for you. So this is an example of us defining great circle distance in Elasticsearch. Maybe not necessarily what you thought you'd be seeing here on the Painless slide. And then what we do is we can actually loop over every one of the warehouses. And so what's interesting about Painless is that we store warehouses as if they're as a nested field. And what this gives us the ability to do is go over each nested field, make a computation based on distance and any other attributes like margin or ratings or anything else like that, and actually compute kind of a score for each item of a nested field. This was something that was new to us because we couldn't actually get to this with typical nested queries in Elastic. It's easy to get the min or the max of a nested field, but it's not easy to get a value per each warehouse to come back out. So this was really a big win because the business did have a lot of pretty sophisticated logic that we'd imbued into SQL in the past. And being able to do things like what we have laid out here within X miles, within a Y margin, and do these kind of sophisticated multi-step calculations was really nice. And I think it helped us gain a lot of trust from the business folks, right? And they were very good about working with us and making sure that we were able to kind of meet their demands, which sometimes felt a little crazy at the beginning, but we were able to get this. And I do want to give a special shout out to Jitin Modi. He's the developer that actually kind of engineered this. Myself and Dan Worley, my colleague, originally went into this with a lot of skepticism, but it's sometimes good to be proven wrong, right? And so it was a really nice win to be able to see this actually come to fruition and see it get pushed out into production too. So yeah, but with Painless kind of comes great responsibility, right? We're writing all of our own scoring on the fly with Painless, so we don't have any of the safeguards that an Elastic query would have. And so if you're gonna follow this strategy, you do have to really make sure that you are always checking a field exists before you go to query it. You'll get some nice null pointer exceptions in the Painless script itself if you don't, and also make sure that you never return negative scores, right? This gets to be a problem if you ever find yourself dividing or infinite ranges too, dividing by zeros, things like that, where you can kind of trip yourself up and get into situations where scores are either non-positive or not defined, and Elastic will complain about that. So you have to put your own guardrails back on, essentially. The next step of this thing is adding weights. And now that you have these components translated in Painless scripts, what we do to kind of add another level of customization or flexibility to it is weight each component. And so if you think of this top one as the original merch score, where you have ratings as 25, price is 25, distance is 50%, you can see a balanced merch score on the bottom. And I want to call this out because it's a big win for flexibility and testing. right? If you separate these two concepts so that the weight is its own entity and the script is its own entity, then you can kind of just store the weights as if they were params. And so this is painless syntax where, again, instead of having a weight hard coded here as a float, you can actually reference this params list essentially that goes and gets passed along with the script in, and Elastic will just do this replacement for you on the fly. So this lets us do things like quickly A/B test different weight configs and move things around really easily in terms of checking. The third step in making one of these merge scores in Elastic is to actually index and compile the scripts. This is mainly for Elastic performance reasons. And I think of it, what's really happening is compiling it, but I think of it like an index job. You post a script with the ID you want to use. Here I'm using rating score into the cluster at large. It doesn't actually live at the index, it lives at the cluster level. That's just a technical detail. But the goal here is to kind of save compile time. Elastic knows what it's going to get. And then when you want to go use it in an actual search query, you just reference it by that ID that you passed on this original post. And when you reference it, you can go ahead and pass that weight or that list in, where we're passing weight here is the only thing, but there's no limit here. You could pass in as many params as you wanted to, and they'd be subbed in and out. So just, yeah, that's that. So, and then finally, this is how it all kind of sticks together, is we put all of these different components inside of a big bool should, right? And so this is a linear combination of these different weighted pieces. And it's the same things that we showed in step 2 about adding weights, but now we're just doing it after we've already indexed the scripts. So we're referencing things by ID from step 3, and then we can just go through, and now we have a ranking function that's going to just kind of score products in the way that we want to, the business logic that we want to imbue in terms of that ranking.
All right. And so just as Nate just showed in the previous slide, we have the different segments of Painless Script and the weights. Well, they're all stored in our database. So even though you see the weights written out there in the script for the example of our talk, really those are all being passed in and figured out on the fly, all being stored in our database. So this allows us, I guess, the most amount of flexibility. So here you can see our merge score is built up of those different subsections of different subscores, and that gives us the entire baseline merge score for our product. And again, that's all kept in a database, and which makes it, great for if we just want to change a weight, or if we want to change something about one of the subscores, or if we want to have, some A/B testing and switch out the baseline merge score for something else. We can do that all on the fly, and just repost the scripts, like you mentioned, or reindex, and we're good to go. And we can do that, anytime.
Yeah, and another big win that's on our roadmap for the next 6 months is getting this into a proper back office front end, so that we can kind of start to really empower people that are working in the business analytics team and the promotion analytics groups to be able to kind of lean in and learn a little bit of Painless. These are people that are already writing sophisticated formulas and kind of workbench tooling like Excel or Tableau. So we know they have the coding ability to do it. And we want to be able to really take this and kind of spread it out to the non-search teams at SimpleTire too. So that's another strong reason why we like having the DB in the back end, because it fits with existing back office tooling. But ultimately, this is kind of what the business people always cared about when we were like, well, look how cool this Painless script is thing we wrote. They're like, well, is it helping us actually kind of get to better conversion rates? And sure enough, it is, right? And so we saw a lifted bottom line by porting this existing SQL into Elasticsearch. It was a plus 3% on the conversion rate in terms of purchases. And we were very, very, very happy with that. But right now, all that meant was that we were just ranking the search results as they came back. Right? The browsing experience on SimpleTire is actually a little more complicated than just search results, right? So what we want to really be able to do is take this idea of the baseline merge score and expand it out into like this customized array of clones, right? And each one of these clones is kind of a riff on that original merge score. It might have some of the same components. It might have all of the same components in different weights, or it might just have its own mix of components, right? The world is kind of your oyster in this thing because of how flexible Painless is. And we're storing all of this in the DB so we can quickly kind of pick and choose the pieces that we want to bring in and out, and then define weights for each of them. So it really sets us up well to be able to take what we just walked through in those steps and expand it out until your heart's content, right? So the goal here really in terms of the site is to capture this kind of Netflix style browsing experience, right? The inventory is all tires, and some of it can be hard to see when you go to select a tire for your vehicle. You're faced with hundreds of options. So what we really want to do, just like Netflix does, is provide you these customized slices of the index, things that we know from doing user research matter to different segments of our user population, right? Some people just want to know what the most popular tires purchased in your location is, right? Who's buying what when the winter months are coming in, because I live in Utah and that matters, right? Maybe I don't live, I just want to know what the best value is to me. And this is kind of a combination that we derive with pricing, warranty, and rating, right? What the best long-term tire is for my vehicle and my pocket. This goes on and on and on. And on any given page, we have somewhere between 5 and 8 of these kind of customized, what we call curations. But really, under the hood, all of these curations are in fact merge scores, right?
Right. So going back to this slide, previously we just had the one vertical baseline merge score, but we built it in a way that you can have as many. So those slices, each one of these represents one of those slices, one of those Netflix style menus. So best rated, best warranty, most popular. And the interesting thing is here, the way we did it as well, you can share, these subscores with each other. So you don't have to recreate the wheel every time. You just say, oh, I want to have best warranty. It's similar to best rated, except I want to swap out, review score and warranty score for price and best rated, or most popular, I want to have previous sales instead of distance. So you can figure out, you can create new subscores, you can create new slices and just drop them in there. And the great thing about this also that I don't think we mentioned yet is that these are all, for performance reasons, these are all running at the same time. So using multi-query, right? Multi-search. Yeah. So that was a really big win because, as you can imagine, doing all these computations on the fly, does take a little bit of CPU, but we are running them simultaneously, and that really is pretty fast. I hope you guys will actually try it.
Yeah, please try it. Not too many of you try it, but and I think one thing that I'll call out in a second too is like Marc said, each one of those curations is a query. So when we implemented the first one, this is kind of waves of development effort. We added one kind of script score intensive query, right? As soon as we brought curations over to the Elastic side of things, we just took that one script score intensive query and kind of 8x'd it, right? So we asked a lot more of our clusters, but even still bringing it over to Elastic gave us a slight lift on conversion rate. So we saw a +1 uptick from actually migrating away from SQL and into Elastic, but also here we gained a lot of, I think it was a moment of paying down kind of tech debt and understanding, right? We had this big kind of monolithic script score SQL job running, curating these things. And we were constantly faced with questions of why does this product appear in this position on this list? And no one was really well positioned within the org at large to go in and be able to detangle those. And so bringing all of this ranking logic over to Elastic was actually a big win. Even if we didn't see as big of a lift in terms of conversion rate, we did see a big win in terms of manageability and understandability that I think just now, even the business and the purchasing groups are really starting to enjoy, right? It's much easier for us to sit down and have those communications now that it's kind of all under this Elastic domain, which is really exciting. So like I alluded to earlier though, when we 8x the script score load that we're asking of our Elastic cluster, we ran into some CPU problems, right? And this might be where some of that painless idea comes from, right? It's super CPU intensive, and you can see us just bouncing nodes off of the 100% line over here. And we're just watching kind of index response times and search response times hit the roof. So we're actually noticing slowdowns in production, which we expected a little bit. I don't think we expected quite as much. And we're just kind of sitting there watching the world burn for a little bit. But this whole project is hosted on Elastic Cloud. And so to kind of get us away from this problem, CPU hitting the ceiling, hitting the rails on, we just shifted our instance config. So out of the box, Elastic Cloud puts you on a balanced high IO plan. We shifted over into a CPU optimized plan. We lost a little bit of storage. That's not a big deal for us. We have a relatively small index, but the lift in CPU did give us enough of breathing room, if you will, so that we weren't noticing slowdowns on the production site anymore. But just like any good developer story, I wanted to throw in a little blurb about bugs that we found doing this in the wild. So this is after we actually switched over to doing the CPU optimized Elastic config. We were still seeing relatively high CPU options. And if anyone wants to just throw something into the chat, the question here is, what do these two have in common? This drop right here from 80% down to 15%, and this buoy moored in the middle of the ocean. If anyone has any ideas, I'd love someone to shout them into chat, and I'll rely on Charlie if you see anything good. Oh, there's, I just want to, David Harris, I think, just wins a pair of, I don't know, OSC socks or stickers, and he's exactly right. So we thought our location algorithm was pretty good. The answer isn't Africa. The answer is actually Null Island. So Null Island sits on the prime meridian and the equator, and it's the coordinate 0, 0. And we don't ship to Null Island. We don't even ship outside of the US. But figuring this out and seeing the amount of queries that we're throwing over to Elastic with the lat long coordinate 0, 0 is the user's location. Maybe that's because of private browsing. Maybe it's because of cookie blockers. Whatever it is, it led to a massive reduction in terms of the CPU load on our cluster. We're still scratching our heads a little bit about how many requests we're actually able to get to that kind of Null Island problem set. But either way, it was a big win for us. And now we have a lot more breathing room than we did before in terms of CPU load. So always, I think, double check your assumptions, and especially in location tracking, right? Remember, we took the safeguards off essentially when we went this painless route. So it's on us now to make sure we're not doing anything crazy. So I just want to kind of recap here, because these are just two rankers that are kind of sitting there for you, doing things in real time, curations and merge score. But really the holy grail of this is personalization, right? We know that we have a really talented analytics team behind us, giving us all of this insights about people's browsing journeys, depending on where they come from and where they come from. Maybe they start on an ad, maybe they start looking at an individual product. But what we really, really wanted to be able to do when we started this project is deliver a personalized, a really tailored merchandising experience. And we actually layer on another merch score, if you will, in Elastic's rescore block to do this. And so it's a tweak on top of that existing should block. The should block stays as it was, but we actually rescore products to kind of elevate some products that we think you're more likely to purchase based on one of those past signals.
All right. So here what we're showing is one of those curation slices, and without personalization. So this is still using our merge score. So this is being returned ranked how the business would like it based on the merge score. So when you're seeing these slices of data, everything that Nate has talked about previously is going on here. These tires are sorted for someone that's in PA. You can see their customers in PA, and so it's taken into consideration distance to the customer, price, reviews, and this is your basic sort without the personalization. What we see here, if you're not familiar with the tire industry, is a mix, right? So there's Pirelli, which is a high-end tire with maybe some different lower tier tires mixed in. But if we move further, so if a customer, lands on a Michelin brand page, either they browse there or they were directed there via an ad. Now they can, now when they get to the same tire search at 235, 60, R18, their results are a lot different. In this case, they're looking at all Michelins, which is not always the case. There could be a mix here. It just so happens that for this tire size, the Michelins are rescored enough that they're all showing up under the best rated. But the idea here would be, even if you're not seeing all Michelin, you might be seeing a mix of Michelin and comparable tires. So looking at a different example, if someone looks at an Atturo brand page, same thing, browse there or directed there, and then searches the same tire size, 235/60 R18, they're now seeing a mixture of tier 3 and 4 tires. So most of these are tier 3. I think the General is a tier 4. And really what this comes from is, as Nate mentioned, we're building this off of what the entire company has been involved with. So we have analytics and user site experience studies that tell us that if someone comes in and they come in looking at a Michelin, they're most likely going to buy a Michelin or a higher end tire similar to a Michelin. So what we're trying to do here is bring that to the user. When they're searching, they're going to see what they're most likely to buy, or what we think they're going to buy, and we just elevate those into the result set, and there you have your personalized curation. And again, I mean, we can try this. I would love for you guys to try it, but what you're seeing here is real time, all those Painless Scripts, running simultaneously, all those distance calculations. It's pretty fast, and it's pretty awesome. Another view of it is, if you're not looking at the Netflix style menus, you can always hit view all just to see your result list. And this slide here, I just put together so you can see, like, without personalization, you're actually getting a mix of 3s and 2s, mostly 3s and 2s. You don't get a tier 1 until you're way down here, 9 tires later. And then, but if you did visit the Michelin brand page, you can see that the mix is completely different, right? You're seeing mostly tier 1s and tier 2s. You do get a tier 3 in here, and I'll explain that in a second. Versus the tier 3 tire, which again is a mix of mostly tier 3 tires. And interestingly enough, you see in all 3 of these, like in the without personalization, you see a tier 1. In the tier 1 view, you see a tier 3, and I believe it's kind of covered here. There's a tier 2 in the tier 3 look, and the reason for that is the rest of the merge score, right? So some other part of the score, one of those other sub scores was strong enough, like reviews or previous sales, something else pushed that tire into this group that allows it to be, in this set, even though it's not a tier 1 or tier 2 tire. So this Scepter, for example, must have really good reviews or good sales, and that has brought it into the picture. But that's what the side-by-side view looks like.
Yep. And that's something that we're still kind of working on as an open problem, right? What is the right level to bring in these rescore factors? What is the right level to blend this stuff? And that's some really exciting tooling coming up next on our roadmap to make sure that we're getting all of this stuff into the right balance, if you will, and being able to share that with the business team. So, but the biggest win for all of this was the biggest lift that we got out of any of these experiments so far. And it turns out personalization is important. So a 5% jump on conversion rate for the most lift out of any of these. And it really was kind of a nice affirmation for us after going through a lot of sweat. Can we do this? Can we keep the cluster alive? To really see at the end of the day that it was totally worth it. A big business win. And I think we made a lot of friends across the organization by doing this. So it was a great way to leverage a lot of smart people across a bunch of different teams to actually drive something that's having big impacts on the bottom line. So that's our talk.
Yeah, so just some shameless plugs here. We are hiring. So visit us, SimpleTire.com, or you can see here, SimpleTire, applytojob.com. Look for some great roles there. Yep. And for anyone here, we have a promo, Haystack 5. We'll give you 5% off on top of any promo. Yeah. So any existing promo that's out there, another 5% off using that code on our site.
So Eric Pugh, if you're watching this talk and you need to buy a couple tires for maybe a Honda Fit or Toyota 4Runner, take advantage of this awesome opportunity. Any questions?
Fantastic. Thanks, chaps. That was great. Somebody says on the chat, I've got my tires. I just need the rest of the car now. So we've got questions already. Thanks, guys. Firstly, Deepak is going to ask how often these ranking weights are changed in the database.
So I think what we typically do is we add what we call a new merge score. So each time we kind of shift weightings around, we give it a new name, even if the weights are going to change. So we'll have weight config A, weight config B, weight config C, if it's all on the same merge score. And that's just kind of like a sprint cycle change. They come in as new tickets, and then
Right.
I don't know if you're going to take it.
Oh, well, I mean, the question really, so hitting on how often, right now we're not changing it that often just because it's still relatively new in production, maybe I want to say 6 weeks old. So we're really, we tweaked it in the beginning, and now we're just letting it settle, and so we can see the results, and then we'll work with the analytics and BI team to figure out and sales team to figure out our next tweak. So we're not tweaking it like every day. We're collecting some data right now.
We do rotate in and out which curations show. Those go in and out based on activity, but we don't necessarily create new ones every week. So,
Great, gotcha. Okay, that's another question for the Zoom, but people in the room do think about your questions. MBD asks, what's the pipeline for personalization data?
That's a great question. So I'm not 100% sure I'm the best person to answer that. Essentially, the personalization data now revolves around brand pages visited,
Ads
visited, trying to think, tier of the page visited, and we essentially, I don't know about the pipeline there. We're storing a local cookie to grab that. We check if that exists, and then we kind of kick off the logic in our middle layer, which is written in PHP Symfony. It's a Symfony app. Kick off that logic and add that rescore clause to that query as it goes off to retrieve results from Elastic based on the presence absence of that cookie. Right? We don't do a rescore if we don't have any information on you, but if we do, we'd like to take advantage of it and give you a better ranking.
and postal code. So ahead of the personalization, even for the baseline merge score, we're using your postal code if we have it. So if you've given it to us, or we're figuring it out from your IP, we can use that to figure out the distance queries.
Right, thank you. Do we have any questions from the room?
It looks like there is not.
Okay, thank you, Susan. So next from Zoom, how big is your index? How many docs in your index?
I think we're cruising at 60,000 tires right now, so really small index, but yeah, I think that's kind of, that's one of the big call outs of this, right? We thought about including the disclaimer slide. I don't think this is going to work well if you have to do this across millions of queries. Lots of the ways that we set up our queries in Elastic too, we're filtering hard by size. So for any given size, speed, load combo, right? You can't put trailer tires on that Honda Fit. You need to actually, we already have pretty restrictive filters in place, which are packaged in the Bulls filters. And that gets us down to a couple hundred results in any given set, where we really have to only hit those couple of hundred with this painless scripting. So I'm not sure where the upper bound is. This is something that came up with my colleague Bertrand too. I know painless does slow down a bit when you have to loop over large result sets and do this stuff. So it's a great call out from Danius.
Right. What we showed here in the talk is ultimately the result of getting to a size. And we are using Elasticsearch for that as well. So we have a type ahead search, which as a customer, you're going to come in and you're going to either search by size or vehicle, but ultimately you're going to have a size. And like Nate said, hopefully you'll have a speed and load rating, which means you've chosen a vehicle, and then that reduces the set.
Gotcha. Okay, so another question here from Zoom. Juan Carlos asks, is there a way to do these scripts for scoring in Solar?
I don't know. I don't think so, but the best way to get an answer on the internet is give an answer and have people tell you you're wrong. So I'm going to say no, and then wait for one of the people that's smarter than I am in this room to tell us you can.
I know we do have a solar committer in the room. Eric, do you know of anything equivalent in solar?
I don't know that I've seen anything that goes that deep the way Painless does. I mean, there's lots of function queries that can change your scope, but I'm not sure that there's anything that takes such a strong I'm a script run me approach.
Okay, thank you. Well, that sounds like a big old issue for Jira. So let's get a solar equivalent of Painless. Somebody asked, Nabin asks, besides some manual guardrails you put for the Painless scripts, was there any test coverage for the scripts themselves, since they are actually embedded in the queries?
Yeah, I mean, you can validate Painless scripts. This is kind of one of the requirements of when we roll this out into back office for letting other folks write Painless. We're going to add a button to validate, right? You can't save without a successful validation, and give some kind of UI feedback to make sure the queries are valid. I mean, it's really easy for me, and I think for everyone, to forget what is it, semicolon and Painless have some confusing behavior. I mean, we definitely spent some time debugging things.
And we also have our test cases.
Right. Yeah, we wrote unit tests to kind of make sure all of these rankers were happening, make sure cookie presence or param presence was triggering differences in rankings. So.
Fantastic. Thank you.
Question,
Raphael has an index of 1 billion documents, is slightly worried about doing this kind of stuff at query time. But Dan Worley, another part of the OSC team who's also worked on SimpleTire, says if you can limit the rescoring to a small window, then this still may be possible. So don't be doing your Painless scripts over 1 billion documents, I think is the message there. And LP asks, did you try any offline testing or metrics to come up with the weights, or are you looking on the online performance to come up with a set of weights?
Yeah, so that's a great question, LP. And so, like I kind of alluded to briefly earlier, there was kind of a whole year of this market optimization for figuring out which weights helped get us to an ideal ranking in an offline fashion, working with that marketing consultancy and the business team. And what we're doing now, we just rolled it out, or it's about to go out, right? The PL product list page boost config tests, right? This is the first thing that we're kind of testing. And now that we have access to quickly change config on the fly, we're rolling out A/B tests to see which weighting schemas are going to produce more conversions, right? So that's kind of one of the big things that this got us to, is the ability to kind of seamlessly do A/B tests by flicking and flagging different params around right on the fly. We're not beholden to waiting for values to come into the index. We can kind of change them as we go. So we're looking forward to A/B testing it now to seeing if we can get any additional lift, right? Because all of the weights we saw today are kind of driven by that original offline.
That's it. Thank you. And I think the last question we have on the Zoom, Max Irwin from OSC mentions that, of course, streaming expressions in Solar, you can do a lot with it, and that's possible. We could look at that as a way of calculating some of these scores. Obviously, completely different architecture and way of thinking about things than Painless scripting. Okay, do we have any other questions from the room? Fantastic.
Doesn't look like it.
Okay, thank you. So I think we'll leave it there, and just our thanks to Nate and Marc. It's been a great collaboration with SimpleTire. We've really enjoyed working with the team there, and the collaboration continues. So yeah, if you need your tires, you now know where to go.